Hey everybody, welcome to another CS302 assignment, and for assignment 3 I guess we're going to have fun with sorting. I guess it's not the best name for an assignment, but I guess we're going to have to try to somehow enjoy sorting. So for this assignment, we're going to basically implement insertion sort and merge sort, similar to you've covered these in class. But the pseudocode and trace through all used an array type of format. So we're going to modify insertion sort and merge sort with a linked list data structure, similar to this linked list class we implemented for assignment 1, but it'll be a little bit modified. And of course, the idea is we're going to compare and contrast insertion sort and merge sort. And it also will be a write-up portion, which I'll have a separate PDF for that, a write-up portion to compare and contrast and analyze the runtime of your insertion sort and merge sort algorithms. Anyway, let's go ahead and now talk about the linked list class. Okay, so there's our linked list class. And then once again, we have, well, the struct node. It'll be, again, a doubly linked list. It'll be templated, which, of course, our main insertion sort and merge sort algorithms are going to be sorting integers. But again, we'll have it as a template class. So we're going to do some, I guess you can call it unit tests on our linked list class. I'll have string, or sort of a linked list of string objects we'll be using instead for our testing purposes. So that part's the same. Then of course we have our node star head, node star tail, our head and tail pointers, and we're going to have also a size variable that will denote how many elements we have in our linked list. Now, this size t variable is just really an unsigned long. It's just really able to store a very big positive integer. So treat this as just a very big integer. That's all size t is. So for Iterator class, it is the identical Iterator class from assignment 1. Same thing, no difference. Iterator, we have our private members, so our Iterator object contains a current pointer, and that current pointer is going to store the address of a node. So that's going to be essentially tells the Iterator which node it points to. Then of course we have our constructors, our dereference operator, and hopefully this time I have the correct sort of operators here. So you have the prefix plus plus and postfix plus plus, and I hope this time, I think they are correct this time around. And then same for minus minus. Then we have our comparisons, same idea. And now we have our linked list class, and for most parts about the same. So we have our default constructor, which I wrote that for you. Copy constructor, the same as in assignment 1. I'm not going to actually test the copy constructors in this assignment, but you still may need to actually have, at the very least, you will need to have your assignment operator correctly working, because we are going to be returning linked list objects through recursive function calls, and it's going to involve calling this operator, the assignment operator, to correctly deep copy linked lists as we return them up the recursive call tree when we implement merge sort. But I'm not going to test explicitly, but you're going to need to do this. The destructor, you will need this because I will actually check your code for memory leaks. You do want to have a destructor. Again, we have our begin end iterator. Nothing fancy there. So far, all this is about the same. You could literally take your code from assignment 1 and just copy and paste it here, because it will be no different at all. Then begin and end, I wrote that for you. So remember, begin returns iterator whose current points to the head, and the end is a function that returns an iterator whose current points to the tail node. Get size function that returns the size, so nothing fancy there either. This void pushback function is actually the same exact function like from assignment 1. Is empty. This one's a simple one. It just returns true if the list is empty and false otherwise. You can see it's written for you right there, so you're good also. So now these 4 functions are going to be the differences from assignment 1 and assignment 3. So there's no swap nodes, at least. That's has to be somewhat relieving. Now these will be a little bit tricky because again, we're going to push elements and insert elements in a very fancy way. Because remember how linked lists work. We can pick up a node and move it somewhere else in our linked list. So these functions are going to be exactly doing that fancy sort of movement of nodes. And I will, of course, on one node here, draw out some examples for these. And of course, at the very end, we include our LLCPAP so we can link this together, so we can separate our header file from implementation file, so we can, of course, then can easily we can, of course, can link these several different mains. And of course, this way you won't be able to modify the header file because the header file will be linked in code grade. And of course, I have all the documentation right here. Some of the functions were sort of hard to actually document nicely, so I would suggest for these last 4 functions, this video will go over a more visual example of how they will work. And afterwards, we will talk about, so input output is the same like in assignment 1. So we'll go over the insertion sort and merge sort functions after I cover these 4 functions here in our linked list class. So anyway, let's go ahead and begin the more detailed explanation of these functions. Okay, so for these 2 functions right here, I'll highlight these. For the pushback, which takes an iterator as a parameter, and then pop front that returns an iterator, let's cover this right here. So suppose we have these 2 linked lists. The first linked list right here, this will be, I guess, list 1. And the second one will be, I guess, list 2. Now, suppose we called this pushback function, the regular one that we have from assignment 1, because we will have to use this pushback function originally when we have to construct our linked list. So originally in main, you have an empty linked list. You have to read your input file to read your numbers in one by one, and you have to push them back one at a time. But now let's consider, now that we have these lists already created, so this is just a hypothetical example, these 2 functions are going to be used when you have to merge 2 sorted linked lists together. So this will be a good example of how the merge is going to somewhat work. But again, I'll mention that later on. So suppose I want to remove 3 and push it in the back of this linked list. So of course we could do the old-fashioned pop front, which will just deallocate the front node, and then call this pushback function, pass in 3, which will push 3 right there. But that's not a bad idea, but wouldn't it be cooler if we could just instead, let me see if I can use the pen to correctly do this. I want to actually, okay, this pen is not highlighting. There it goes. Okay, it's having a hard time highlighting. Okay, I'll use the mouse then instead. So I want to do this. I want to grab this node, pick it up, and put it right there. And then, of course, the head pointer would have to be reassigned to that node. That's what I want to actually do. That's way more fancier than destroying the first node and then maybe copying data field into a temporary variable and then recreating it there. That's not really so fancy. So just sort of doing that move where I can just pick this up and put it right there would be a lot cooler. Or at least that's kind of one of the benefits, or the not so benefits, because of course this is going to be a bit more trickier, but it is cooler to do this with linked list instead. So what's going to happen is the first thing we'll do is we'll call this pop front function, which returns an iterator object. So here's my IT right there. Let me see if I can move down a little bit. There we go. So suppose I can do something like IT equals list 1 dot pop front. So the result of this will be as follows. So we go back to my linked list. Let me just move this up. There we go. What's going to happen is I'm going to create this iterator variable. Iterator contains a current field within it, so I'll put the current right there. But current is a private member within the iterator. But we're going to have it where what's going to happen first is we're going to have to move the head pointer to its new position, because after we do a pop front, we don't want this head pointer to point here. We want the head to point there. So we're going to have to actually move the head pointer over. So I'll try to fit this here if I can. Maybe I should rewrite this actually. So let's put the head right here. I'll just put the IT current right there so it's easier to actually work with. So in our function, we're going to first, well, of course, you have to check to make sure our list is not empty. And also, you could have a case where head and tail could both point to the same node. So you have to also make sure that we take care of those edge cases, but it's just a more generic case right here. And then what we have to do is you have to set the heads previous to point to null, because we're going to cut off this node. And of course, you can probably even set this node's next to be null as well. So within the function body, you have to have maybe a local iterator object that's going to be assigned to this node 3. The head will move to the right, and we're going to set the heads previous to null. So it cuts off this block. And of course, you want to set this node's next to be null as well. And then we're going to return the address of this node in a form of an iterator. So then that way, back in main, I can sort of scroll down here, it's going to assign IT to point to that node. So now IT will point to this node. And then what I'll do is I'll just say list2 dot push back. Now you could cheat and say, oh, I'm going to say push back star IT, and it would end up calling this function. But if you do that, it's defeating the purpose of this, and this actually could, in fact, potentially could cause memory leak in your program. So it's also bad for 2 reasons, but of course it's not really fancy. So you will check to make sure you don't actually try to do this in your merging function of merge sort. So you want to actually instead call pushback, but not pass in the dereference iterator, but the actual iterator IT itself. And it's going to end up calling this pushback function, where I call you could of course can shrink the name of this if you want, but this is sort of the iterator called node to be pushed back. So what's going to happen now? I went too far up. Let's go over here. What's going to happen now is I will just sort of temporarily will move this so it's easier to visualize. So I'll just move this over here like so. And the result is we're going to have to just do this. We can just simply set the tails next to point to this node, so that iterator node to be pushed back dot current will contain the address, because right now it's going to be not IT anymore. It's going to be now node to be, why did I call it so, why give it a long name, push back. That's okay. Okay. So we can set the tail next to point to this node, this iterator's current. And we can set this node's, or this iterator's current arrow previous to point back to the tail. And then just move the tail to now be assigned to this iterator's current. So then tail will then move over here. And you can see here that we popped 3 off of our first linked list and pushed into our second linked list without having to have to deallocate and allocate. We just simply, we grab the address of that node and just put it into our second linked list. So we're going to be doing this. You'll have to essentially use this functionality when we're going to do merge. You can have 2 sorted lists. You have to pop the front nodes and then push the smaller value onto your merged linked list one by one until you finally have one merged sorted list. But that's going to be the idea of what this pop front and push back will do. So of course you have to check for edge cases as always, but that's the general idea. So you don't want to deallocate, reallocate. You want to return the address of that node, and then of course you want to return the address of that node in the form of an iterator. Then you want to take the iterator and pass in the pushback, which will just insert that already existing node into the other linked list. Okay, so now let's go ahead and go over the last 2 functions, which will be SpliceOut and Insertion. These 2 are going to be used in your Insertion Sort main. Let's go ahead and discuss these next. Okay, so let's go ahead and now consider the spliced the SpliceOut function, and insertion functions. So SpliceOut is going to essentially remove a node. It's going to pull a node out of your linked list, and it's going to return the address of that node in a form of an iterator. And of course, then when we splice out a node, we can insert this node somewhere else. So let's consider the following. What if, let's say I want to pull 5. I want to remove 5 out of the list, and I want to insert it between 3 and 7. Now remember, for insertion sort, if you remember that C++ code, when let's say we want to shuffle, let's say you want to insert 5 between 3 and 7. So the inner loop for insertion sort, remember, it keeps on moving elements over to the right to make room for 5 to come between 3 and 7. Now this is actually not this is not accurate in that sense, but suppose we wanted to put 5 between 3 and 7, we have to move 2 to the right, 7 to the right, and put 5 in between. But with linked lists, we don't have to actually shuffle things around because we can easily squeeze the node in between 2 fairly simply. So right now, let's go ahead and do exactly that. So I'm going to, let's suppose I'm going to set my I iterator. I guess I'm going to call this just list. So suppose this linked list is an, in fact, I actually declared it list right there. So we have list dot begin. So then essentially I points right here to that first node, and I'll move it over actually 3 times. So we have I++, and then I++, which is going to eventually move the iterator right here. So you have to move it 1, 2, 3 times. Perfect. So I want to splice out this node. So to splice it out, I'm going to go ahead and just say j equals list dot splice. Let me see this. It's splice out. Okay, splice out, and I'll pass in I like this. So what splice out is going to do is going to essentially, within the function body, we're going to have to create some additional iterators or pointers in the function because we have to have 2 and 4 linked together, so then 5 is not in the picture anymore. So the result is going to be really just this. I'm just make it a bit nicer visually for right now. I'll just go ahead and just do this and see how this works out. I say good enough. So we have this situation. So we have it where 5 points back to 2, 2 points to 5, 4 points. So we have this. I just simply, if you will, I kind of pulled on the node 5 and pulled it back like a slingshot for a second. So we kind of pulled it back like this. So to splice this out, we have to essentially remove this node, and we're going to remove it by doing this. I'm going to set 2 to point to 5's right neighbor. I'm going to go ahead and set 4 to point to 5's left neighbor. Then I will actually set 5's previous and next to be null just to be safe. So essentially now, this node 5 is no longer part of my linked list anymore. So I'm going to try to actually, let me go ahead and copy, let me move the 4 over and see how this works. I'll use the mouse here. So the result will be like this. Okay, Control Shift to get this perfect. So we end up getting this situation. This picture happens. So, and then we're going to return an iterator whose address contains that node, and j is going to be assigned this element essentially. Now, the I iterator, before you actually even return, you want to set I to point to the node after where I pointed originally. So I originally pointed 5, which was between 2 and 4. So we have reference parameter for a splice out function, if you see right there. We're actually going to set I to then actually point to this node, and we're going to return that node in some temporary iterators. So we can create additional iterators in our function splice out. It gets returned, and then essentially j is going to be assigned this, because splice out function returns that node, which 5 we want to splice out, because I originally was pointing to 5. The end result is that we have to link up the neighbors of 5 to each other, reassign I to point to the next node, and of course if you have some temporary iterator, point to this node 5, return that iterator, and J will catch that node's address. Now we spliced it out. So we didn't actually deallocate it, we removed it, but we didn't lose the address because J, this iterator, contains the address of that node we just removed, or spliced out, sorry. And now I want to insert between 3 and 7. So what I can do right now is just say k equals list dot begin, which will assign k to point to the first node in the linked list. So then k will be assigned to that node. Now for the insertion function, so in this case k is going to be location of LL, and then j is going to be node to be inserted. This insertion function, when I go ahead and call insertion, let me just call it right here, we would go ahead and say list dot insertion, and I'll pass in k and j. So I want to insert a node that j points to into the position right after k in my linked list. So k would be location of LL, and j would be your node to be inserted. I want to insert this node right after this node k, because k is going to point to a node in the linked list. I want to assign this after k. So what's going to happen now, so more fun and more drawings you have to do here. So to do this, all we have to do essentially, so let me just try to move some stuff around here. I guess the pen doesn't really allow me to do this. I'll use the mouse. Okay. So you want to have 5 between 3 and 7. So here's k. We can, within the function body, we can set another pointer iterator to node after k. So we can, of course, easily link where 3 and 5 link up, and then 5 and 7 have to link up. But of course, we have k, we have j, or we have location of LL, we have node to be inserted, and we can create additional temporary pointer or iterator within the function body, which refers to this 7 node. And the result is going to be just simply, we have to just link these all up together. Oh, okay, that was too much. It's always a little bit tricky to, there we go. There we go. Like this. Now I'm not going to actually redraw it, but you can imagine if I were to pull on the head and tail nodes, 5 would actually go between 3 and 7. So it's a much more fancier way to be able to, as you can say, move nodes around. So instead of shuffling elements around like with an array, we can just sort of splice a node out, and then we can just insert between nodes, between 2 nodes, just like that. So this is sort of our visual representation along with our code as to how we would call this in main. So for all of our functions that I went over in this one node, I do actually have some test mains that will just test out and make sure that your splice out, insertion, and of course your iterator pushback and pop front functions work correctly. So if those are working, then you can feel pretty confident approaching the insertion sort and merge sort algorithms. Let's go ahead now and discuss the mains you're going to have to write. Okay, so the input, similar to assignment 1. In fact, I'm going to use the same exact inputs like from assignment 1. Although I'm going to have a few additional inputs we're going to be using for the write-up portion, but just for testing on code grade, we'll have the same input files like from assignment 1. There's 3 input files, and of course there's just going to be a set of integers, and you can use a Linux redirection to read in the values, and of course push them back one by one to create your initial linked list. Now, of course, for the output, you want at the end, after you implement your sorting algorithms, after you sort the arrays, you want to then just output the arrays, similar to assignment 1. So If you recall, this is actually the insertion sort that was covered in class. So you have these nested for loops like this. So you want to, of course, just modify this a little bit for iterators. So the I, key, and j, these three elements are going to actually not be integers. These will all be iterators. So I will be iterator, so will j, and so will key. So you can set the I to point to the second node of your linked list originally. So what you can do is you can have a statement where you can set iterator I equal to list.begin, then I++ to move it to the second position, and then have your loop. And of course, you may want to have while loops instead. It might make it a little bit easier than having for loops because it might be easier. Potentially could be easier. So anyway, you're going to have a key which is going to be assigned to whatever is in I. So you do an I assigned to the key, since I and key will both be iterators. Then j will be assigned to I, then j minus minus. And then this while condition right here, well, the modification would be, well, if j equals a nil iterator, it went, all the way to index -1. And of course, comparing j with the key is pretty simple. But the thing is, what you want to do is you want to set the j iterator, to I-1, and then just keep comparing. So remember, star j and star key are ways you can actually compare the values in each respective node. And then as these conditions are true, you can just keep doing j minus minus. And once you actually hit the end, either j is equal to negative or j is a nil, or once this condition is false, like from insertion sort, here's where you would have to actually splice out the key and insert the key into the jth position, or not jth position, but remember when you call the insertion, you pass in j, it assigns it to the element right after j. So I kind of had it like that, so that way it's kind of correlates nicely with this statement. But you have to then splice out key and then call the insertion, pass in j and key into the function. And then that's going to insert the key to the right position. Then, of course, increment I by 1 to the right, and then keep doing this again and again. So you have to simply take this code right here and modify it a little bit, where you're going to have I, key, and j are iterators. You have to make use of the splicing out and insertions to move the key out of its position and put it to the right spot in the list. So I guess that's all I have to say about the insertion sort. So this should not take too much time. So from when I had to code this, I got this to work fairly easily. This was not too complicated to work on. Now, of course, the more complicated one to implement, which you will, of course, witness is when you work on this, is going to be the merge sort function. Let's go ahead and discuss the merge sort next. So you're going to have a separate main file. So your first main would be insertion sort.cpp. I will provide that main in the zip file on Canvas. And your second main you have to work on will be the merge sort function. So basically, you have to, again, take merge and merge sort and modify it slightly for our version of merge sort, since we're using iterators. So merge sort, remember, we had to first check for this base case. So when you first call merge sort in your program, you're going to have to actually pass in the array, pass in the begin and end. So in main, after you construct the array, you pass an iterator. So here's your merge sort function provided for you right here in this PDF. You can pass in the array by reference and pass in, I call it front, and then the other iterator is called back. So you just pass in the front and back elements, or begin and end iterators, into the function initially. And then what you have to do is you have to have mid. Mid is not going to be an integer. Mid is going to be an iterator. So you have to move this iterator into the somewhere near the middle position of the linked list. You have to, of course, get the size of the linked list, divide that by 2, and then move the middle iterator the correct number of times over to the right to get into the right spot. And then you have to call merge sort on the left half and the right half. very similar to this, except you would have to, not use mid plus 1 because mid would be an iterator, not an array, or sorry, not an index. Now, the only difference I have is that in my merge sort function, it's going to return a linked list object. So you have to have two assignment statements over here. So you have to have, maybe you can create some local variable, call it ll_int, and then maybe the variable name could be called left list. And then you assign that equal to the result of the recursive call function. And then you have to call merge sort on the right half. And in our version, to make this easier, which this does actually simplify this a little bit, it's going to return also an actual linked list. It returns, you want to assign it into a local, maybe a local linked list object defined in the merge sort function. And of course, here's where you're going to have to actually use the assignment operator to correctly deep copy the lists over. And then you have the left side and right side, you have to then just pass in. So you have to pass, so you have to then call merge. And merge, if you noticed, it's going to pass in the left linked list and the right linked list. So the merge function is a bit more challenging, but when we do a merge, you're going to have your two lists. So what you're going to have to do is call pop front on each of the lists, compare them with each other, and the smaller of the two, you just have to push that back into a local linked list function you have to probably define in the merge function. Remember, you have to use the iterator, so you have to call pop from, which returns two iterators. You can compare the values by dereferencing two iterators, and then you can just push back that element to the back of some local linked list object. But of course, you want to pass the iterator and not the actual integer, the iterator, and it will just push that node in the back of your merged linked list. And once every node has been popped off the two linked lists and pushed onto that merged linked list, then essentially you're done. Then you can return that merged linked list. And of course, it gets returned back to the previous function. And that function will, of course, do its merging and so forth. So again, you have to modify this code a little bit to make it work with the iterators. So as you can see there, I mean, if I would have had you implement merge sort using arrays, the code's already available. So I don't think I can't imagine anybody who would ever implement merge sort like this or insertion sort like this. This is kind of why I have that, because it makes it a little bit challenging to find too much code online, or hopefully it's hard to find code online for this. So anyway, let's go ahead and now just run, or show some sample runs of our code, and then end this video.